Folks. Thanks so much for joining us today. This is the first in our series of six heat pump webinars that we'll have going this spring and summer. This one is focused on new construction heat pump considerations and designs for new homes. We'll cover ground source heat pumps, air source heat pumps, including air to water and air to air heat pump considerations. So my name is Diego Betts. I am the Energy Programs Coordinator here at Walking Mountains up in Avon, Colorado. We're excited to have this series again this summer. Just a few housekeeping items before we get rolling here. This webinar is being recorded, and the recording will be available to view on our YouTube page after a couple of days. We'll also send a follow-up email to everybody who's registered for this. Even if you couldn't join us live, we'll include a link to the recording, our slides, and some further information about all the incentives available. We will have time for questions and answers at the end of Dave's presentation. So we have a Q&A box down at the bottom of your screen. So if you have any questions you'd like answered, please enter them at any time in that Q&A box, and we will cover all of those at the end. We won't be using the chat function today. So if there are any technical issues, if you're experiencing any problems with the webinar, please raise your hand and let us know. I will actually enable the chat for our guests to send us a message. Yeah, so moving along here, this is the remaining schedule for our webinars throughout the rest of the spring here. So today is focused on new construction. Next week, we will have a contractor-focused webinar. After that, we will talk about heat pump retrofits for homes with duct systems. April 30th, we have a home weatherization electrification webinar, really focused on creating an affordable plan to implement electrification in your home. On May 7th, we have a webinar focused on heat pump water heaters, both for existing and new home applications. And then June 4th, we'll talk about heat pumps for homes with in-floor radiant heat. Just wanted to give a big shout out to all the sponsors for our webinar series. We really couldn't do this without everybody's support. We've been able to reach a really big audience over these past few years, thanks in no small part to all of these sponsors. So Beneficial Electrification League of Colorado, Energy Smart Colorado, Holy Cross Energy, Tri-State Generation and Transmission, CORE, or the Community Office for Resource Efficiency in the Roaring Fork Valley, and CLEAR, Clean Energy Economy for the Region, partner in Garfield County. So thanks again for everybody's support. A little bit of information about our sponsors coming up here. So loveelectric.org and the Beneficial Electrification League of Colorado is a one-stop shop for all of the Colorado heat pump rebate information. They have lots of resources for contractors, including training and technical resources, lots of resources for homeowners as well. You can search for available rebates in your area, find qualified contractors, and learn more about heat pumps in general. And loveelectric.org really outlines all the benefits of switching from gas, propane, or electric resistance heating to efficient electric equipment. You can use their website to look up cost estimates for heat pump applications that would be best for your home. And you can find a list of qualified installers on their website as well. So definitely check it out, loveelectric.org. Energy Smart Colorado is a regional energy efficiency nonprofit that partners with lots of different nonprofits and utilities throughout rural Colorado. You can see the map here. They serve 20 counties within Colorado, and their goal is to make energy improvements simple and affordable for folks. So Walking Mountains is the Energy Smart Colorado partner here in the Eagle River Valley. Core is the Energy Smart partner in the Roaring Fork, and Clear is the Energy Smart partner over in Garfield County. And there are other partners as well across the state. So this is just a quick hit about rebates that are available from these local nonprofit partners. So Core offers rebates for heat pumps of up to $7,500. For income qualified households, they have rebates up to $15,000, and they also provide grants for commercial and multifamily projects. And they provide grants and rebates for new construction as well as existing buildings. Clear facilitates rebates for Glenwood Springs Electric customers, including rebates available to anybody, 50% of your project cost up to $2,000, or 150% area median income households or under, you could get up to $4,000, or you could also apply for their Re-Energize program over in Garfield County. And then Xcel customers can get up to $2,250 per heating ton for cold climate heat pump installations. These rebates from Clear are only for existing buildings. Walking Mountains offers rebates of up to $1,000 for any home in our territory. Commercial buildings can get up to $5,000 for heat pump installations. And we have an income qualified program for folks making up to 150% area median income called Re-Energize Eagle County. So if you think you qualify for that, definitely encourage you to enroll for our Re-Energize program. And again, our rebates are only for existing buildings. We do not rebate any new construction. Holy Cross Energy has a great rebate program for all electric new construction. They'll rebate 25% of the total cost for any of that qualifying equipment you see listed there, up to $15,000 for a new home. The home cannot have a gas line running to it. This is, again, just for all electric new construction in Holy Cross territory. If you have further questions, go to that website, holycross.com/contact, and they can get you rolling. Holy Cross Energy also has an excellent new on-bill repayment program that just launched at the start of this year. For heat pump retrofits, folks can pay for up to $15,000 on their energy bill over 10 years. And they will stack all of the available incentives and rebates on the front end and take care of the contractor payments as well. Tri-State Generation and Transmission is another of our sponsors, and they also have recently launched an on-bill repayment program. They offer low interest rates, terms up to 10 years, and there's no credit check for this program. It's not available in all locations yet, but it is coming soon. And they do offer some bonus incentives if you go through their on-bill repayment program. So very exciting stuff in Tri-State territory as well. Xcel Energy does have a good all-electric new home program for folks using participating builders and building to these Energy Star Next Gen and Zero Energy Ready Home standards. You can see kind of a brief overview here of what that entails. And if you want more information for building a new home in Xcel territory, please visit that website that we have linked at the bottom. And happy to introduce our presenter for this webinar today, David Petroy from NTS Energy. David has well over 15 years of experience in a range of renewable energy and sustainability business roles. He was the founder and president of Blue Valley Energy, which is a successful ground source heat pump engineering, design, and installation company in Boulder, Colorado, with over 200 installations throughout the state. During the early 2000s, David led technical sales of solar and energy power systems for residential and small commercial businesses at RMS Electric. And then at Golden Aluminum, which is one of the largest single-site industrial power users in Colorado, Dave was responsible for leading adoption and implementation of facility-wide energy monitoring systems and upgrades to reduce energy consumption on large industrial production processes. Most recently, he did consulting work with Xcel Energy, helping customers understand their energy usage. And in 2017, he launched NTS Energy, a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small commercial companies while promoting the transition to the new energy economy in Colorado. David holds a master's in geophysics from Washington University in St. Louis and a bachelor's in zoology from SUNY Oswego. So I will stop sharing my screen now, and Dave, I'll let you take it away.
All right. Thanks, Diego. Welcome,
Thank you.
everyone. Let me get this sharing going. We had a lot to go over today. Just so you know, so this webinar, we've added a couple little things that'll be in there. One of them, I have a couple slides just introducing ground source heat pumps. I have a couple slides introducing air to water, hydronic heat pumps, and I have a couple slides on heat pump water heaters. Each of those we'll dive in depth. The ground source and the air hydronics we're going to do in the last webinar with Radiance, and we have a separate one on heat pump water heaters. So a lot to cover here. Let's just get going. And so I will start it out. One of the things most people know now, I believe, but heat pumps have really dramatically improved over the last 20 years. I'm going to show a couple slides about the efficiency, major leaps, the capacities. Now they can defrost when it's cold out and go below zero. So that's really what allows heat pumps to work in Colorado. This is just a slide demonstrating the capacity and why that's so important. The bottom axis is outdoor temperatures from 0 to 70. The left vertical axis is how much heat a house needs. The green line is a sort of a typical house up in the high country, a couple 2,000 to 3,000 feet, depending on the house specifically. And so this thin blue line that you see here in the middle of the screen coming down, that basically is where heat pumps were at the turn of the last century. Basically, they could do a good job heating down to about 30 degrees. They were in mild climates, and then there was not adequate heat. Over the last 15, 20 years, the capacity, this blue arrow moving up, has increased. So now this orange line is what really is a cold climate heat pump, where basically if it's producing 48,000 heating or 45,000 at 47 degrees, it holds it all the way to zero. Most of them will tail off some, but basically now you'll notice it intersects that green line way down, anywhere between 10 and 0. And so you have little bits of heating required for supplemental to complement it. But without this, we wouldn't be able to really use them in Colorado. The second thing, which directly ties to cost and operating cost and lowering that heating cost, the left axis is HSPF 2, which says how efficient is a system, and it goes from 0 up to 12. And you can see now, this is over the years, the last 10 years to 2022. 2025, we're about the same. We're right in here because the manufacturer have been working on going to a new refrigerant. So they're basically holding about here. But you'll notice that the blue line is this HSPF 2, and the orange is how much improvement. Now, when you get cold climate heat pumps, they're anywhere from 9 to 10.5. So you've got 25 to 40% improvement over where they were. That's 25 to 40% lower cost. Now, the big question everyone says, and it's it's a real challenge, is the heat pump going to save me money heating and cooling? And I've been working on a calculator with Neil Colway at Sweep. We're going to bring it out in a week or two to try to address this for various states, et cetera. But I tried to summarize it. I want you to look at this upper right diagram here. This is, and it's a little, I think, for a lot of people, counterintuitive. The bottom axis, again, is outdoor temperature. Here I've got it from -20 all the way to 70. And then the vertical axis is the percent of the annual energy used to heat in those temperature bins. And all I want you to see is the orange. 1/3 of this is up in Eagle County. 1/3 of the heating is above 35 degrees. 50% is between 15 and 30 is below 15. Most people, I think, would feel that this yellow is over here. Now, and in fact, in the front range, it's shifted a little even more. So let's look at this left diagram. What's the implications of that? If you look at this outdoor temperature again from -20 to 60, now the vertical axis is really important. That is called the coefficient of performance, 0 to 5. What does that mean? The coefficient of performance says for every 1 unit of energy I put in to a heating system, how many units of heat energy do I get out? And let's look down here at this blue-orange combo. This is actually the yellow, the orange is a 95% gas furnace, and the blue that goes straight across is electric. So basically, it doesn't matter what the outdoor temperature is doing. Those are basically about 1, slightly less than 1, 95%, 0.95. Now, these lines, the ones that come down, the top one is a very efficient air source heat pump system. And you'll notice when it's mild, it's super easy. 4 to 5 units of heat can be moved into a house with 1 unit of electricity. It drops off and generalize around 3 to 2 in the mid temperatures. And then when you get really cold, it's hard. There's still heat in the air, but there's not as much. It's harder to move. But as it gets cooler, it's much harder for the heat pump. The light blue line is just the difference on a hydronic heat pump as opposed to air. So what can we say in general? And this is true in most states, most parts of the country. Above 35 degrees or so, the heat pumps are normally lower cost to heat than the gas furnaces. So that's 1/3 of your heating in Colorado. And I can say that basically the only time it really flips around is if they basically start giving away gas at a price they can't continue to afford. And let's look at the lower left. Lower left, generally gas, gas is pretty not super expensive in the States. And generally because it's a little harder, that gas is normally a little bit lower cost over in here. That's 1/5. This is 1/3. Heat pumps already have an advantage. And then in the middle is it bounces around. It depends on what gas is that year, what your electric bills are, what state you're in. But what I can say is generally they're not way different, plus or minus 10%, back and forth in the middle part. So overall, when you say, well, are heat pumps less expensive to operate? There's a lot of variables, but you can say for certain that certainly in the spring and the fall, almost all conditions, they absolutely are. And then you start to go into this transition zone. So this is to try to give you a sense of why heat pumps are so valuable, because it's really easy for them to move energy. So let's go to the system goals. So we're talking about new homes. What are what's the prime directive? We really want to get a great system in, no problems. I don't want to have the contractor come back. I don't want to have the contractor struggle and have a very difficult time and not do well. The other thing is, what's the best value system? And I think this is really what's kind of nice is you'll see there's options for heat pumps, different kinds of systems, some, better than others, depending on what your goals are. We used to not have those options. The options was, I'm going to put a gas furnace and an air conditioner, and that's the situation. And we should make sure that it qualifies for all these nice rebates. So there's a couple strategies you can think about. One is a whole house ducted system strategy, and that we can do air source or ground source. Like I said, I'll just mention ground source a little bit in this talk. What's the advantages there? You have integrated heating, cooling, air quality, moisture, humidification. but the duct system can impact the architecture and complicate the construction process. However, I always go back and forth about ducts, not ducts, etc. There is one thing good about ducts that I come to appreciate is if ducts are done well and really right, they will kind of last the life of the house. So that's a big deal. And then you can go all electric with little strip heating, or you can go with dual fuel. Then you got the option of mini split, which is great. I mean, we never had this option before. Um, you've got some integration in that, but you do have to have separate fresh air and humidification. They're independent. You've got no ducts, so the architects it's somewhat makes it easier at construction. You do have more equipment to maintain because you've got these indoor units, and you've got this visible indoor units thing. And I'll talk about how to make them look. Ideas you can really make them look better. And then you've got radiant in-floor heating, a combination. You can do boilers and air source. You can do ground source and air source hydronic, but you've got to do two systems in there. And the one last thing I want to say is in the 80s and probably before that, 70s, 80s, 90s, radiant was accepted as really much more comfortable than air. And the gap now is really dramatically reduced for a couple of reasons. One is we have much better insulated houses and windows so things don't feel cold. And the second is with these grounds, with the heat pumps, they run differently. They like to put out just gentle amounts of air and keep the house consistent. So the idea is a well-designed system doesn't have blowing air that feels uncomfortable. So it's really what your priorities are. And I think the big thing about this slide is you want to really look at each floor. In the past, it was I'm going to have one system, I'm going to make it work on all the floors. Somehow it'll be in the basement, mechanical room, and I'll make it all happen. So now when you look at a house with your architect and your builder, it's like, okay, the main floor is usually a challenge. Can I do anything above or below? Do I want drops or chases if I got ducts? If I don't want that kind of stuff, then maybe I'll go mini splits. Second floor is there an attic. Basement. The basements are very different now in my view than in the past. In the past, it would be, oh, you put maybe you finish it off, but you wouldn't really insulate it very well or anything. Now the insulation is fantastic, and I think really one of the big benefits, hardly any energy is used. My basement's well insulated. I work down there all the time. I don't run the heat all year round. I barely run heat. In the summer, I don't really run cooling. So you can heat it with like little bits of electric. The other thing is you can do ERVs. But the downside is you've got to have fresh air in that basement. You can't have a basement sealed like a microwave and work in there. In larger homes, you think about east, west, north, south. So in a one-level home, it's pretty straightforward. You're going to think about, I'm going to put my heat pump in the basement. I think the key thing though now is to spend a little money on zoning. Don't have just one zone. Look at the house. The rooms are laid out, and the bedroom's one side, the rest the other side. Is my house oriented north, south, east, west? Almost every house I work on now has sort of big, great rooms, kitchens with lots of windows in the south. Obviously, that's very different than the backside offices. And then the multi-level home, I would encourage most folks to, rather than you might be able to save a little money by doing one system in the basement and zoning it, but really the thing is you can get most houses second floor, you can get a beautiful little system. You can zone it into two zones, so the master bedroom, suite, and the other rooms, different thermostats, office different thermostats, and basically you have a much more comfortable, super energy efficient house. And you've maybe laid out a few $1,000s more. Maybe you're spending $11 a month, but I don't think you save a little energy. You wouldn't regret it. Now, mini splits, and I think mini split industry is more toward retrofits. However, in a lot of cases, people are considering these, especially if it's a smaller house. And these are the kind of units, the traditional wall. Now, if you're going with a newer home, you can put in these flush mount units. They're pretty nice. This goes between the joists, goes in the middle. This is a floor. They call it a floor unit. I haven't seen many of these installed. I think they're pretty nice, but I don't know why not. But slim duct is kind of nice. That can go up above closets, above bathrooms, and you can get two rooms out of one of these units. So quite nice. And this is where I say some folks, and you can go on the internet and get a lot of ideas. There's a wall unit in there, there's a hidden unit, there's another unit there. If it's a new home, you work with the architects, they really can think of ways to integrate these. And these are good for small homes because realize you kind of have to have a unit per room. Um, you'll see on the internet when you go look at the websites, they say up to 8 units, etc. That's a little bit misleading because what you could make 8 small, tiny units on if you had 8 rooms, but you got to have the sizes of these units with capacities has to be somewhat closely matched. Like they can be a ton or ton and a half different, but really, I'd say counting on 4 of them. So really, you can think about that. And then you can actually combine. Now, if you've got a super insulated house, you want to go this route, it's quite nice. But then you don't want to put these in small rooms. Like I don't want to put them in little bathrooms. I even recently I'm working in a home, a tiny little office. It's like for that one, you kick heat, a small heater. I can do different things to heat that room, which hardly needs any heat at all, rather than spend a few $1,000s for one of these units. Okay. Oops, sorry, my internet just got tiny. All right. So radiant in-floor and air systems. And if you radiant is nice and the combination is really good. I mean, my questions I've always discussing with the customer in the past, it used to be, I'm just going to radiant the whole house. That's my heating, radiant. But if you're going to have a system for cooling, indoor air quality, humidification, fresh air with a heat pump, that's a big deal. That can be your primary system for most of the year. And then you can have a little radiant in the winter, which you run for your ultimate comfort. The question is, do you really need the radiant on every room in the house? What rooms are important? Is it most important for the master suite? I would say 90%, absolutely yes. The office, yes. The kitchen, dining room, yes. But the whole house, I don't know. So one of the things to think about. And all the small rooms, it's pretty easy if you're going to do radiant. Basement, you could put a little radiant in the basement and be done. But you still would need you still want to think about a little fresh air system. So let's go through and talk about heating sources now. So we've talked about air source heat pumps. This is, standard ducted or mini splits. Those are the lowest first cost options. And there's a lot of contractors out there doing this. This is the transition that's happening. Ground source heat pumps, I have a couple slides. If it's a really big house, more than 5 tons, 6 tons, 10 tons, you want the best system for you. It's a very high cost option. The heating costs, it can do 20-25% lower cost to heat and cool. And I'll show some slides about drilling, etc. The air to water hydronic heat pumps, these are very big in Europe. And we have couple of ones that are available in Colorado, Canadian systems, and a few designers. I would say this is a real niche market. The couple people I know doing it do a very good job. It takes a lot of very thoughtful design. But I'd say if you've got a small heating load and you don't want a boiler, but you really want radiant, this is something you might want to consider. This is something I think that there's a lot of misconceptions and there's a little confusion in the market. And if you go on all the manufacturers' websites, the terminology might be a little bit different. But this is the thermometer on the left side, lower efficiency to higher efficiency. HSPF2, which I talked about, goes up. SEER goes up, cooling, and they kind of are matched in parallel, really. And you have 1 speed and 2 speed. 1 speed is, lower, and 2 speed overlaps, but gets a little more efficient. Then you've got variable speed and cold climate up this way. So single and 2 speed, ducted system, simple installation. What I mean by simple is the commissioning in this setup. All the contractors understand. All the controls aren't that sophisticated. This is not the kind of heat pump you want to use for all electric heating. It's not good enough. But if you're going to have natural gas or propane on site for other reasons, um, you could consider it as a dual fuel option. And here's now where it starts to get a little bit confusing because you will see variable speed and capacity inverter systems. And you will see variable speed capacity inverter systems. And then people talk all the time about cold climate system. You don't see this distinction in on most manufacturers' websites. And the thing that this is cold climate. These can be used in our climates, but in a different way. So these are definitely better than these. They work down to zero. This is a nice price jump. This is the big price jump. The difference between the cold climate is this capacity drops off. So these inverter systems, so this one in the middle category might be a 4-ton at 47. It might only be a 2.5 ton at zero. So they're really not adequate for full electric systems in Colorado. They can be combined in a dual fuel option. So that's their idea. But the true cold climates are the ones that can hold the capacity, as I showed you in one of the earlier slides. They heat down to really cold temperatures. And these are kind of the required for all the electric systems rebates and really required if you're going to go all electric, because even though you're going to combine some electric supplemental with it, you don't want to depend on that very much. So ground source, and I only got a couple slides just to introduce it. So you've got a couple kind of units, and that's what's really nice about this industry. They've done a nice job. This is just a simple, looks like a fancy furnace or air handler, and you've got ducts, and it can do it all. The nice thing is this middle here. This is really nice because what this unit does is it does air, but it also can produce hot water for radiant heating in a tank. So what you have over here is you have a nice tank. Usually it'll be an electric water heater because you need something to hold it kind of steady, but the heat pump's doing the majority. So this is a great system if you've got a huge house and you want to really have air, cooling, everything. This is like do it all. And on the right is if you have a house where you don't, for some reason you don't want cooling or you don't want air or something, you just want basic hydronic. I want hydronic heating. You've got this small unit and a tank. Now this one you can put another tank, and you can have a hot tank and a cold tank and an air system, etc. But in most cases you would just go over to this unit. Now they use the ground to give you the heat. They're more efficient. The ground stays steady. There's two kind of loops basically, horizontal and vertical. This is where it started. Horizontal loops in the Midwest. People had lots of land. They could easily dig up trenches, pits, put them in. The soil was moist. It was good. Colorado, not so much. I mean, in the Eastern Plains, you can do this if you got the land. Out near Grand Junction and in spot stuff, the big savings, everyone's, well, I can save a ton of money. Yeah, if you dig your own trenches under the guidance of the loop installer and you backfill on your own, sure. And you can do that. One of the things a little disadvantageous is we have dry soils. The dry soils don't conduct heat as much. So what happens is you have to have a little more loops, a little bigger trenches. Almost probably 80-90% in Colorado, vertical loops. You drill these holes 250 to 350. They're 5 and 6 inches in diameter, 15 feet apart. You put the pipes down and you go. And you can squeeze these in. I've squeezed drill rigs in the smallest places imaginable. So you can do this pretty much anywhere in Colorado. However, if you look at a geology map of Colorado, it is got lots of pretty colors, lots of things. So it's tricky drilling in Colorado because you've got, hard granites. You've got really hard rocks, tough. It's known, but it costs a lot. You've got some in the Front Range, you've got shales, which are easy, but then you've got a lot of alluvial fans, gravel, boulders, which are the hardest. So that's what makes it where everyone's not doing it in Colorado. But it's good. If you ever get it in, it's there forever. The install cost is quite expensive. There's still this 30% federal tax credit. Get it before it goes, which is a big deal. The hydronic systems, this is a picture on the right. They look like the air systems, but they're a little bit bigger. All they're doing is the difference is just over here in this diagram on the left, you've got these units coming in, and instead of going in a coil at the top of the furnace, it basically goes into a little box. There's exchange between the refrigerant and the water, and you've got a tank of hot water. And you usually put electric in this too to help keep it steady and for other times, and then you feed your radiant system. If you want, you can have a second tank cold, and you can have cooling also from that tank. So nice systems, really popular in Europe. It takes a little more design thinking, and that's why there's, like I said, there's a couple folks in Colorado do a really nice job on this, but you do have to really think your design because you've got elevations, which you have to take into account with air source. But in here, these units, they don't output quite as much. So you've got to make sure that you have a big enough system in Colorado. The other thing is the heating. These are really good for in-floor systems. They're not good for baseboard or other systems. And you want to have very low heat. People used to design radiant for boilers, 120 degrees. The problem is hotter water with these systems, you greatly lose your efficiency. So you really want to run it down. You want to have the piping, the insulation, the design, so you can run it really nice and low. I just had a client call and say he was very happy. He ran his floor at 104 degrees through the coldest parts of this winter, and the house was awesome. And so him and his floor designer did a fantastic job. And you got to make sure you've got a big enough system. If it's electrical, your all electric house, you better design it so it can really handle the load down to zero. And their costs less than ground source, but the sad part of it is, or the thing to overcome is they don't really have that 30% tax credit. You got $2,000. So one of the big things all right, what's the heating cost comparison? I gave my generalization. This is specifically house up in Eagle, around 2,000 square feet or so, depending, almost 4 tons. And what I've done here, there's about 2 or 3 programs that everyone uses to model and tell you, oh, size the system, manual J, what's it going to cost? So this is Right Suite, it's definitely the biggest independent one. And basically you put in their different systems, you say, well, what's it going to cost? And so it's really apples to apples in the same house. Now, the big thing is, what's the price? What am I going to assume for gas and electric? What's fair? What makes sense? Well, there's a really good data set called the Energy Information Administration. They get from each state, from all utilities, all the electric data, pricing data, all the residential gas data, every year, all the months, and they publish it from all the big ones. So it's a very consistent, clear data set. Now, I don't want to take the last year of this data set because what we're trying to do is say to you, the homeowner, and you're asking the question, what's going to be more expensive? What am I going to save money on? And we're trying to say over the next few years. Nobody knows what it's going to be like in 10 years, but we're going to try to say over the next few years, how are these going to compare? Am I going to save money? And so this is the 4 years, the December, the winter values for gas, electric, propane. They don't do that, but I took 2 times gas. Basically, propane's 2 to 3 times gas, so a little conservative. This column here is an all gas system. 1659 is what it says it's going to take to do this house over the year. If this was all propane, it'd be basically double that, so about $3,400. Here I've got, so here I've got one. I put in propane. This is a heat pump with a propane furnace. All right, as a little bit of a backup. This could be electrical too. It'd be basically the same. And it's a nice heat pump. And notice 1586. Remember, the propane furnace, 3,300, 54% or more from my experience. This is another option, a new home, 2-stage heat pump. Now, this would only be as if you decided for some other reason you wanted gas inside. If not, then you're going to go all electric. But this one here, couple stage, 2-stage with it, and notice it's about the same, within a few bucks. Here's your nice cold climate heat pump, all electric. And in fact, it saves a few percent versus natural gas. This is averaged over the last 4 years. So then you say, well, what's going to cost me more to put it in? Well, this is kind of a, always a wild card, roll the dice. Um, Prices are all over the place. I talk with a lot of people, talk with Nikki and Diego, what's the price in the Roaring Fork Valley? But really, it's kind of what are these differences? And it's surprising the prices just keep going up. But so this is a furnace, and I should have had propane or gas. I'll have to correct that. 20K. You really don't get any rebates. All electric cold climate heat pump system, it's notably more, 28K. Now, here, Diego talked about the great program Holy Cross has. 15,000 for all electric new home. They didn't put 15 in because you got to buy some other stuff like the heat pump water heater and the stove, etc. But it's 10, that this is the big thing. And actually, Excel has 10 for their first level of all electric. And then you've got the feds. And so it's below, comes in below. And then you've got this dual fuel deal, and you get a little bit from, depending on where you are, like Holy Cross doesn't have, Excel has some of the other utilities have some, and a federal tax credit. The bottom line is both of these come in below this or really close. Now, the beauty is you've got control of things. With this one, you can do a little more gas or electric. This one, you've got sort of the best system. The other thing now is you're going to save on what I like to call air pollution, which we measure in GHG, but it's both. In the Front Range, it's horrible the days when we have ozone problems, etc. So it really is impactful both ways. And this is what this vertical axis is, the annual emissions. I want to see here a car is somewhere in here. So we're like on the order of a car when we're talking about heating your house. And this is in 2022. Now realize Colorado came from a long way back. We used to use almost all coal. And notice the gas furnace is the purple and the heat pumps, this is the hybrid ones and this is the cold climate. So they're on the same order. The heat pumps are here a little lower, this is a little higher. But notice in 2027, I should say, this is kind of an average type numbers. But Excel's on target for doing this, and Holy Cross is incredible how they're dropping things. And so notice, wow, this stays the same, but these are down. And in fact, the lifespan of your system is going to be 2025 to 2040. By 2040, these are going to be down in half. I'm not going to promise these utilities are going to get to zero all renewables, but man, if they get even down to like 75, 80%, these bars are down lower. So this is a tremendous benefit, not just pollution, but really you're using a lot less energy. So I just like to show this because this is the big deal. We're going after this big monster here. And even in the high country, not so important, in Front Range, important. By putting in a really nice heat pump, you actually do, you're trying to put in the best cooling you can. So let's, we're moving along. Let's see what time. Got to get moving. I got to get moving here a little more quickly, but so there's been misconceptions, and it's really because it's not installed right. And then there's really two things. It's not keeping my house warm when it's cold, or man, it costs a lot. And that's because it wasn't sized right. And so you didn't have a big enough system and you use a lot of electric, or you didn't have enough. Now, here's a big thing about these systems as I talked about, cold climates and the difference between the cold climate and the variable speed. All the cold climates are not the same. So you really have to ask your contractors, what's the minimum temperature does it go to? Can you show me the curve at -5, -10, or -13? I mean, I don't know if you don't necessarily have to, but just you can say, how's it perform at these lower temperatures? Does it have enough capacity without me running a lot of electrical or a lot of, if I'm doing dual fuel, furnace? What's the capacity at altitude? So basically, you've got to cut it basically up. Depending, the outdoor units might lose 10% capacity. Indoor units like the might lose 20% capacity. You have to take that into account. So sizing, you want to, what's the design temperature? It's important to know these loads. And I'll say there's one thing, and you had to upsize due to altitude. And I will say this, when in doubt, if you're working with the contractor and builder and they're like, it's about this or this, it doesn't hurt to go up a little bit in size. So here's the trade-off. A few percent efficiency, because the difference between 3.5 ton and 4 ton efficiencies in most of these manufacturers is not a lot, versus making sure that it heats when we have these polar vortexes, and also doesn't rely on the backup. So here's sizing in a pretty picture, a little bit cluttered, but bottom axis -30 to 70 outdoor temperature. This axis is sizing, as the heat required. Now, this solid red line is, oh, I ran my model for this house, and it tells me it needs this much heat. Now, many people in the industry will say the models overdo it. Well, they might. You can't say the model's going to overdo it in every house, but let's just say it's a band. So I don't really know exactly how much it's going to need, but it's something in this band. And now the cold climate heat pump. Well, they give you the factory specs, and it sits on a factory floor or a testing floor, and it's tested under beautiful conditions, but it gets out in the real world, snow, ice, wind, 5 years old, maybe long line sets. So there's a range in here, of how it's going to operate. The idea is, though, you want this to meet somewhere, if you're all electric, somewhere around the 5 to -5. It's got to carry that capacity. This is where it's got to meet. If it's meeting way back here, not good. Call, complaint, huge bills. If it's meeting way up here, probably too big. I got to make big ducks for no reason at all. So that's where you want to do it. Now, the key here is the number of hours. These black lines in this axis is the number of hours per year that we're really in these cold temps. And that's kind of interesting. This thin line is the number of hours. And notice when it gets below 0, it gets below 80 hours. Here's about 20 hours. So the way I like to think about it is in here, up in the high country, maybe you'll have 5 to 7 nights cold like this on a normal winter, maybe another 4 or 5 nights. Now, in a cold winter, it might go up. We might have 2 polar vortexes. In a warm winter, might have none. So you got to take that into account. How many hours am I going to be doing with a little extra electrical backup here? So I don't need to repeat myself, but basically you're going to size it so it can do it when it's really cold. I don't want to use a lot of supplemental. I can go with this 2-stage furnace supplemental with gas. If you have gas for other reasons, don't let this be the driver of gas, but it's an option. You don't have to size it as much down because gas is less expensive. When in doubt, size it up. Now, so in the past, when I was doing ground source heat pumps, man, we just put them in and we would just put in a big electrical backup and be like, all right, we need a big electrical backup, man. If this thing shuts down when it's super cold, that's to heat the whole house. That's not a great plan anymore, because if everybody does that, the utility is unhappy. You can't have that. So really what you got to do is you look at that curve that I said and you say, how much difference do I have? My heat pump's running. I'm not going to put in a huge amount of electrical. If it's 10K or more, that's too much. You've undersized the system. 3 to 7 is really what you want to need. And you can have masonry stoves or something, because the problem is these big circuits, you got to have a bigger panel, costs more, bigger lines. It's not worth it. Now, something coming on, smart panels. I know Holy Cross is working a lot on. I think some of the other utilities sharing circuits. Now there's some individual devices you can share circuits. I'll tell you, EV charging with this backup electrical is a great share, because you basically say, hey, when it's super cold, my electrical is the priority. That means you might not EV charge for a couple hours for 5 nights of the year in the middle of winter. I got to say something about mini splits. Try to keep moving fast. The thing about mini splits indoors, you got to size each one for the unit. You don't want to oversize these because they blow too much, but you want to have enough. And also you have limited capacity. I've got to have them matching. So here's the thing. If I have a 4-ton outdoor unit, I can do like a 24 and two 12s. All right. I can have that much. I can't do a 30 and a 6. Too much separation. So there are limitations in the smallest unit and the biggest. And typically you can go a little bit over the outdoor unit capacity because they rotate how they need it. So like if I have a 4-ton system, I can use, say it's 48. So I could go with a 24, an 18, and a 12, which would be a little bit more, but that would be okay. Heat pump, let me go faster here. Quality heat pumps. I can go online and order stuff that's super inexpensive. Um, the problem is, this is a key thing. I don't know. So what's the warranty? What's the compressor warranty? If I'm buying a new house, I might consider getting the extended warranty. Most of these are like 7 years. You might pay extra and say, what's the 10-year? And the contractors that get really comfortable are the distributors that carry that product line, because that's a key thing. Are there even parts around to fix it? These are some really good cold climate brand examples. Let me go through this fast. Locating it, it's nice to locate on the southeast side. It's kind of nice to keep it out of the weather if possible, from direct weather. Often you can put some soft bushes or hardscaping around it. And you want to keep noise considerations. I mean, they're making them quieter and quieter, but in the spring and the fall, if I'm out on a patio, I don't want this thing next to me. I'm not going to put under bedroom windows. Keep it above the snow, unless you love to shovel this out. Put snow shelter on top. Make sure everything's well insulated. I'll go through this quick. Ducts. These are beautiful ducts. This is key, and I think there's a lot more inspection of these. But when done great and the right zoning, they work really well. Mini splits. You've got sort of this tension because you want to try to keep the lines set runs to a minimum, but you also want to put the outdoor units in good spots. And that's part of the reason, separate units for different floors, that helps do that. Last couple slides, a heat pump water heater. So, and we have a whole webinar on this, but since you're building a new house, wanted to go through this. So it basically draws air from the room, extracts the heat, and heats the water. And the way you can think about it is, you have a big mechanical room or a medium-sized mechanical room. Your house is heated. The mechanical room by default might stay to be in the mid 60s. All this is doing is saying, for a couple, 2-3 times a day, when it needs to heat the tank, it'll draw the heat from that room. The room temp might go down 50 degrees into the 50s or so. It sucks all the heat in, puts it in the water. You don't go in that room. You don't notice it. Over the next 5-6 hours, that room heats up again. It sucks the heat out again. So it's a very efficient way to use sort of excess heat in the house, saves a lot of money, and it uses only 1/3 of an electric water heater. So it really cuts if the option is electric water heater, cuts it down. It's about the same as natural gas. This is a heat pump water heater, looks similar installed. You need a big enough room to put it in. Or if it's not big enough, you can put wall grills in, or you can put a duct to adjacent big room. I wouldn't put it next to a bedroom or something. The best way to get the most energy out of this with new homes is you plan on having ducts to the wall. It has, a kit. Air comes from the outside in the summer. It uses all the heat in the summer hot air, heats the water, and then you have a duct going to the outside in the summer. And you have little dampers, and you have inside. So for 6 months of the year in the high country, 7.5 in the Front Range, you set the dampers, free heat from outside. Costs hardly anything to heat your water. Flip it in the winter, it does it that. So I'm not going to read through this. You'll be getting this in your inbox. A lot of the stuff I said, and thank you for your patience. A lot of material to get through, but we're opening for questions.
Yeah, thanks so much, Dave. That was definitely very informative and glad we were able to get it all in time.
Right.
If anybody has any questions they'd like to ask, feel free to raise your hand. I can let you speak, or you can throw it in the Q&A box. Um, Here we go. So Omar's asking, in Eagle County, have you done research on the price differences between a gas and a heat pump furnace?
Um, I have not done a formal one. There is actually the state has just they hired someone to do a very extensive analysis of heat pumps versus gas throughout the state. And the numbers they came out were somewhere between 8 and 10,000. And this is, keeping up with what contractors are bidding, talking with Diego and that. So it's kind of knowing individual jobs, looking at quotes, getting this information from this study. So I've put in 8,000. I think that's probably pretty close. If it's 10,000, I think still it would be a little, still with the rebates be a bit under. Um, so you're right. We do the best, try to keep on all the latest bids and talk to people. And I think this study actually was quite good too. So
Yeah,
that's
thanks, Dave. And I'll just add that, yeah, up here in Eagle County, there certainly is a price difference for heat pump systems versus furnace replacement. It kind of depends what existing furnace you have. If it's already a condensing furnace, there's less cost involved to just replace the furnace. But if you're adding a heat pump, um, the initial installation cost is higher, but you are also adding cooling to your home. So if you were to compare the cost of replacing your furnace and installing a standard air conditioning unit, it's pretty on par with just installing a normal cold climate heat pump.
that
Um,
was just that's Omar. That's what we compared, like AC furnace. Now, obviously, if it's just a furnace, it's a big deal. It's a lot less. It's like 12 grand, probably something like that. That's just the way it is. But in a way, it's not apples to apples. And if you're doing a new home, which this one is, then it depends. It depends what you want.
yep. Thanks, Dave.
Did answer your question.
Any other questions out there? We can hold on just another minute here. Um, oh, Omar asked again, what about monthly bill differences? That it's highly dependent on your specific home, your insulation levels, your air leakage, if you have a duct system versus if you do a mini split heat pump. What we've seen generally is that the operating costs are roughly equal if you already have a high efficiency gas furnace. If you have a lower efficiency gas furnace, so like an 80 percenter, then your operating costs will likely drop somewhat with the cold climate heat pump. And if you do some weatherization in your home, if you address any insulation and air leakage, that definitely helps the uh, performance of the heat pump, and that helps keep your costs down as well. So highly dependent on your individual situation. If you are more curious about what your operating costs might be, definitely encourage you to get a home energy assessment. If you're here in the Eagle River Valley, we can give you a report that'll outline all of those cost differences and potential operating costs for you based on some details from your home.
Yeah, so that was that one. I did that one model. So if you look at the average Colorado price for the last 4 years, and you compare like a super good cold climate heat pump, electrical versus a 95% gas, those systems run pretty much on par. They're pretty much, and in fact, you can. You can know it by just the ratios. So, in fact, in Eagle, depending if you're on Holy Cross, their average price of electrical is a little bit less. It's like 13 cents, or you're a little bit off. Now, if you happen to go with a dual fuel, you have an advantage that you can set the point outdoor temperature at which it converts over from heat pump to gas. So if gas is very expensive that year, you can have the heat pumps go down to 20 degrees. And then the gas just does that. If the gas is cheap and you want to go up, you can go up to 35 degrees. So in those cases, it can be on par, or the heat pump can be better because you control and have the flexibility. In the super cold climate all electrics right now, because of the big jump in efficiency, and in fact, with the newer units, I showed you that improvement. 10.5 was like the upper end, but now that's becoming kind of more the norm. This new refrigerant, I just looked the other day, all the manufacturers are coming out with a 10.5 HSPF2, which is really, really efficient. So, so basically over the last 4 years up there, things are pretty close on par. There's not huge differences.
Great. Well, Omar, hope that answered your question. Um, Great. Not seeing any other questions, so just want to thank everybody again for joining us today. And hopefully we'll see you on our upcoming webinars starting next week as well. Thanks again for everybody's time, and thank you so much, Dave, for your great presentation.
Thank you.
Have a great night, everybody.